Hi everyone, and welcome back to another episode of Dr. Kyle Explains, your YouTube channel where we go through GCSE science content quickly and easily. Another big thank you to everyone who is helping out by giving the video a thumbs up and subscribing to the channel. It really helps out and it makes this channel grow further. Today we're going through the transition metals. Now this is a triple only topic, and so if you are doing either the Synergy or the Trilogy award and not the triple, then feel free to give the video a thumbs up, subscribe to the channel, but move on to the next. If you are doing the triples topic, please stick around for more great content. Let's go ahead and jump in. Okay, so first of all, I just want to highlight where the transition metals are. So they are essentially in this middle section here in the periodic table. So these are the transition metals here. And then just to highlight everyone, we've got group 1 at the top here and group 2. And remember, they're quite reactive. They get more reactive going down the group. Then over on this side, we have group 7, also known as the halogens. And remember, in previous videos, they get more reactive going up the group. And then finally, we have group 0, also known as the noble gases. And so today we're going to be focusing on this middle section around here called the transition metals. Okay, so some key information then for the transition metals. So as we've already said, it's the group in the middle of the periodic table. All have similar properties which are different from the metals of group 1. And so remember, group 1 metals are quite reactive, whereas the transition metals generally are quite unreactive, and we'll be going through in further detail in this video about that. So some examples include chromium, manganese, iron, cobalt, nickel and copper. Now you don't have to learn all of the transition metals, but it is a good idea to have a few in the back of your head to give examples if you need to. So I've just written some down here. Some other common ones you've probably heard of are things like titanium, gold, silver, things like that. As I said, you don't have to learn all of them, but it is a really good idea to know at least a few of them. So, properties of the transition metals then. So you can essentially divide the properties of the transition metals into two categories. You've got physical properties and you've got chemical properties. Let's do the physical ones first. So, transition metals are hard, they have high density, they often have high melting points, and they are strong. And so if you think about some transition metals you would see in everyday life, such as iron, copper, maybe titanium, a little less common, but maybe zinc as well you would see. And you'll often find that these are all obviously transition metals, but they're often used in construction. And that's because they are hard, have high density, and they're strong. Okay, and so these are physical properties that allow us to use them for construction materials. Now, the chemical properties of the transition metals are that they have low reactivity, especially with things like water, oxygen and chlorine. They form coloured compounds, and this is a special property that you specifically need to know for GCSE. They can be used as catalysts, and they form multiple ions. Now, what this section here means, multiple ions, is it essentially, you know, in regards to maybe something like iron, it has the ion Fe2+, or Fe3+. You can have copper +2, copper +1, and all of the transition metals can form multiple ions. Whereas if you look at group 1, you can only have sodium +1 because it loses that one electron and forms a positive ion, but it's only ever +1. It just wants to lose one electron and form +1. The same as potassium will only form +1 ion. Whereas the transition metals, we can form multiple ions. So that's what we mean by that. It's often sometimes referred to as the oxidation state, which is that little number at the top here. So the 2, 3, 2, 1, and the 1 and the 1 here. So that's the oxidation state. So multiple oxidation states, multiple ions. Now again, looking at the properties of the chemical properties, think about it in terms of the transition metals. Iron, low reactivity, copper, titanium, zinc, all low reactivity metals. And so we use them for construction materials because they're hard and they're strong, but also they react quite lowly in terms of everyday life. So with water and oxygen, if we used potassium, for example, to make a bridge, it would be absolutely awful because it's very soft and would collapse easy if you put any weight on it. And also, every time it rained, it would go up in flames. A very poor material to make a bridge, even though it would be probably quite funny. Okay, so comparing it with group 1 then. So specifically for your GCSE, there will be questions where you would have to write and compare between the group 1 and the transition metals. And I've summarized this here in a table for you. So I would really recommend you go through this table and learn these differences. So just to highlight then, group 1 are soft. So we've seen before where we've gone through the group 1 metals, you can cut into potassium, you can actually squash it with a knife, you can cut into sodium, you can cut into lithium. So just with, a butter knife, you could push through it and cut into it. Whereas a transition metal, I'm sure you've seen things like iron, your bikes are made of iron, chairs are made of iron. I'm sure you've seen copper pipes before. You have to, really saw through them, or you have to use, advanced pliers and things like this in order to get through them. They are very, very hard. Group 1 have low density. Remember, they float on water, whereas transition metals, if you put them in water, they'll sink to the bottom. Group 1, extremely reactive with things like oxygen, chlorine and water. Remember, we explained why that is using DFE in a previous video, which I'd really recommend you go back and watch if you haven't already. Transition metals, very low reactivity. So think about gold, for example, as a transition metal. We use gold as jewelry on our skin. And so it's really low down in the reactivity series. Most of the transition metals are. Even something like iron, which is a little bit higher in the reactivity series, if you put it in water, it takes days in order for it to rust. As opposed to sodium and potassium, you put that in water, reacts straight away. Now, this is where we talk about the coloured compounds. So transition metals are often used in things like paints and stained glass windows, to make coloured compounds, and they add colour to our life. And the reason for that is because they form these multiple oxidation states. Now, for your GCSE, you just need to know that the transition metals form coloured compounds, as opposed to thinking like group 1 metals, so such as sodium chloride, which is table salt. It's a white compound. Potassium chloride, a white compound. Potassium iodide is a white compound. And so they either form colourless or just plain white compounds. The transition metals often form coloured compounds. And if you just simply Google transition metal colours, you will see the complete array that the transition metals make. And some of them are really quite beautiful. So, group 1, I've said not used as catalyst here. I mean, occasionally they are, but generally they're not used as catalysts. Whereas the transition metals, again, because they form these multiple ions, they can be used as catalysts, those things to speed up reactions. And as we said in the previous slide, so group 1 metals only form +1 ions, whereas the transition metals can form multiple ions. So just really quickly again, things like sodium +1, lithium +1. And so if you had a formula here, it might be Na plus, and then you'd have your Cl minus. You might have Na, 2, and then your oxygen. But remember, your oxygen is -2, so therefore you need 2 sodiums to balance that charge. That sodium is still +2. Whereas over here, you might have FeO, so that's +2 and -2. Or you could have Fe2, O6, so that would be -6 there, and then therefore your iron would be in a +3 oxidation state, 2 of those, so +6 there. So you can form multiple ions for your iron. So all you really need to know, group 1 can only form +1, whereas the transition metals can form multiple ions. I'll go through this in a further video just to clarify that about how you actually make your formulas. Okay, so what we've done today then is we've described the properties of the transition metals and we've compared them to the group 1 metals. Thank you very much for watching. Please do go through my other playlists to find more GCSE science content. Please give the video a thumbs up, subscribe to the channel if you haven't already, and do please keep telling other people to allow the channel to grow. Remember, if you ever need any more help with your GCSE science content, Dr. Kyle explains. Thanks very much. Bye-bye.